Okay. Yeah. Welcome to another day. I think it's time that we actually get some programming in. I feel like doing some C. I'm actually not that good in C, so I kind of want to learn it from the very beginning. And why don't you just help me learn and go along with me? So the book I'm using is Head First C, right? I just found it in this GitHub repository here, Media Lib C Lib. I guess I could just kind of what is it? You can kind of just link that here. It also has this Brian Kernighan and Dennis Ritchie book on C, but I kind of want to use something a little bit more modern because I'm guessing that C has changed a lot since then, but not so much. So I'll link that inside this repo. And let me just add let's see, another day. Um, should have just been doing that earlier, but yeah, let's just do C books here. And then um, I decided to use head first C, and we can get that in here, C, and then head first C. So directly, you might have to download it manually. Oh, it loads. Okay, yeah, just download it manually, and then you can probably just open up the PDF here. I'll kick that off to the side, right? Um, just kind of link that here, and we're just gonna take it slow. We're just going to just create little programs and go through chapters together, and at the same time like what we can do is kind of just make again our system more tolerable, right, in terms of just user experience on Linux, right? And yeah, we'll go from there. um Before I get started in coding, I do want to make my font size a little smaller now. So hopefully that's not too small for the video. And I also, I guess, want to take this chance to make the dock a little smaller too. Now that I'm watching these videos, so no, not here, here. So let's make that 24, and that that gives me like 8 pixels. Okay, so here and here, and then we'll just kind of extend that. Okay, I need a tiling window manager soon. But anyway, yeah, let's go through this book. We'll just get kick right into chapter one. I think like the intro book is just telling us how to approach the problem and like how to study programming, because programming is not for everybody initially. I believe anybody can learn to code, but it just doesn't feel natural at first, right? And just learning how to um, think like in terms of logic, like think step by step, is actually a hurdle that a lot of people um, generally have problems with in the beginning. It was for me too. So yeah, but yeah, I don't think I'm too far off from beginner level. I know how to write C, but not that good again. So yeah. So let's motivate ourselves. Diving in. Don't you just love the deep blue sea? Come on in. The water's lovely. All right, I'll dive in, but I don't know how to swim. um, so want to get inside the computer's head. Let's see. Need to write high performance code for a new game, program an Arduino, or use that advanced third party library on your iPhone app? If so, then C's here to help. C works at a much lower level than most other languages, so understanding C gives you a much better idea of what's really going on. C can even help you better understand other languages as well. So dive in and grab your compiler, and you'll soon get started in no time. I'm excited already. So yeah, so apparently C is for small, fast programs. It's very performant. It's compiled and strongly typed. So the gist is that you write a C program here in your favorite text editor, and then you compile your C program, right, written in this you save this file, right, as rocks.c, and then you compile it using this GCC tool. And we actually installed GCC when we had installed build essential in our post install script. So we go back to our post install script, we had build essential right here, which we installed. And then after that, once we compiled our program, we have a binary file, which we can actually run as a program in our terminal in this case. So yeah, this tells us that there's actually 3 standards. I didn't pre-read any of this, but I kind of get the gist of what the book is trying to say. So I'll just quickly summarize things. So there's 3 standards of C that over time, right? The first standardized C was ANSI, and that was made in I think like 88 or something like late 80s. That's what the Brian Kernighan and Dennis Ritchie C programming or the C programming language book is based on, right? And C99 was like a revision to that first standard. And I think that's like one of the more common ones in use today. And then there's a new one or more recent one called C11. And I think since then there have been several iterations, but I feel, well, from what I've heard, a lot of code hasn't really been written in these newer standards yet. So that's the reason why I chose this book, because at least we're learning C11 based off of what this book is kind of hinting at. So before we do anything, I'd like to actually change the font for the editor. So let's see here. So we're using Droid Sans Mono, but I want my Cascadia Cove, so I'm gonna change to Cascadia Cove Nerd Font Mono. Okay, and then I also want to enable ligatures, so I'll do ligatures, and then I'll enable ligatures. Oh, it's already changed. Okay, and let's test it. If I did this, do I get ligatures? Yes, I do. Great, cool. We're pretty set here. All right. Okay. So yeah, so let's kind of just go over quickly what we think of what these code snippets do, right? So we see that we have a integer. We declare an integer called card count, and we assign that to 11. So then if card count is greater than 10, which it is, right, it's 11, then we, I guess, puts, I'm guessing this means put string, right? Puts the string, the deck is hot, increased bet, right? To the screen. So I'm assuming that's what it does. So now we declare variable c, which is integer 10, right? So while c is greater than 0, which it is, like 10 is greater than 0, we want to put the string, right? Puts I must not write code in class. And since this is a while loop, it's going to iterate again at some point, right? So what we do is we decrement the counter, which is going to be C here, right, to 9. And then we just go through the check again. If while C is greater than 0, 9 is greater than 0, then we put I must not write code in class. Then we decrement again, and C now becomes 8. So then we go back up, and if 8 is greater than 0, then we execute this all the way until when we have C is 1, right? We put I must not write code in class one more time, and then we decrement 1 minus 1 becomes 0, and then we go back up again, and then we check is C, which is 0, greater than 0? No, it's not. So then the while loop finally ends. Okay? So these are like nice exercises to to kind of get used to the code structure. I don't think the book expects the reader to actually like know this code, since I'm assuming it's written for beginners. But if you can guess, just guess. But in case we're trying to solve it, so we're not guessing. So here we declare a character array. It looks like character, right? Char. So this is what I mean by C is like strongly typed. It's like when you declare variables, it's not like Python or JavaScript where you can just kind of declare any variable and not really think about its type, right? For example, you could do like let x equals 5, right? And then do x equals Bob somewhere down the line in like Python or JavaScript if it's just plain old Python, plain old JavaScript. But here in C, it's like if you declare something to be an integer, then you can only assign integers to it. If you declare something to be like a character array, then you can really only assign character arrays to it. So here we declare a character array that has 20 elements, right? We we I guess output the string puts enter boyfriend's name, right? And I'm guessing then we uh, expect to receive about 19 characters of input, okay? And why 19? Let's think about it. So we want to receive 19 characters of input and actually put those characters into this array. That means we have one extra element, right? That we can like free inside our array. Actually, in C, in every string, uh, that the very last character in a string is an invisible character. It's like a special character called the null terminating character. And what that looks like in code is actually something like this. Ooh, right? So null terminating. The character actually looks like this. So it's like a backslash zero, right? That's like an escape character, and a zero to indicate that it's a null character. And that usually signifies like the end of a string. Um, if we don't have something like that, then potentially your C program can, if it's trying to like iterate through a string of characters, it can potentially just keep going and going and going, expecting to find this character to stop, right? And that can cause a lot of bugs and crashes because then you start veering off into like nowhere land in memory or somebody else's memory, right? Because again, like strings, integers, all these things are actually stored in memory. And in this case here, a character array like the um how should I say this variable, right? This ex variable kind of points to the first element in that memory block holding all those characters. So yeah, so we get 19 characters, and I'm assuming that then automatically we'll have a null terminating character at the end. And yeah, we end up printing that string, right? The printf is like a formatted print with a %s. I think that's like one of those like like placeholders, and we replace this placeholder with the ex character array. Cool. Let's see here. So now here we declare a character called suit. It's the character H. Then we have a switch statement where it'll check what's inside suit. And basically if it's a C, it'll put into the screen, I guess, clubs. And if it's D, it'll put diamonds. If it's H, it'll put hearts. And then if it doesn't know anything else, it'll put spades. Right? So in this case, it's going to output hearts in this case. Okay, cool. And here are the answers, right? So I think we got them all right, right? So we display a message. Okay, that's what we did. And then, yeah, basically, as long as the value is positive, we display a message and decrease the count for this. Then create an array of 20 characters, display a message on the screen, store what the user enters into the array, display a message including text entered. Okay, that's what we did too. And then this one's straightforward. So we create a character variable, store the letter H, which we said, and then we look at the value of the variable. So that's what the switch does. We ask ourselves, is it C, is it D, is it H? And otherwise, we do whatever is in here by default. So easy enough, right? This part of the book or the chapter tells us what a C program looks like. So basically in C, you're always going to have a structure that looks similar to this in the C file. And I think I could just jump ahead. Like, I think this is kind of confusing, so I'm just going to write a quicker example here. And it's a hello world example, right? So then I'm going to create a new folder. Instead of naming this packages, I'll rename this projects. And then I'm going to say that this is going to be C, right? And then I'll put another folder called JavaScript. And I'll put this in here, move, and now I have a fresh C folder. Cool. Okay, so I'm gonna make a new folder. I'm gonna call it Hello World, and I'm gonna make a file in here called main.c. So all C program files end with the .c extension. Do you want to install the recommended C or C++ extension pack extension from Microsoft for the C language? Yeah, yeah. I need all the help I can get. I definitely need all the help I can get for this one. Yeah, C is hard, so I want to do well. So yeah, go ahead and install the C extension pack, everybody. So okay. So where are we? Okay, yeah. So yeah, this page tells us like the basic structure of a C program, but I'm just gonna like write one that's easier than the one that's shown. So basically, a basic C program io.h almost always looks like this. Okay. So, and we need a new line at the end. Okay. So the basic file will include any libraries we want. In this case, we include something called like standard IO, which is like the standard functions available to us to do stuff with input output in C, right? In this case, a good example of standard IO would be this printf function here that we don't get for free until we actually import this, right? And it'll make more sense once I show you. And in every C program, you'll have something called a main function, where it's something that will get run automatically. It's like a special function, right? That your I guess like the compiler looks for to add as like an entry point to your program. So like your program will always like call main first, right? And then from there, you can call any other functions you want, but we always start at main. So this main function here is like the only one we have right now, but we can have possibly like 10 other functions, but they're not named main. And then basically we'll always call main, and if we want to call like our other 10 functions, we'll call it from the main function. Okay. And inside our main function, we just have a simple printf function call, right? So this is a function call with a string passed in, right, as an argument to this function. Just simply hello world with a backslash n, which signifies a new line, right? And then we'll just return 0 as an exit code from our program. And it's like good practice to return some sort of exit code, in especially in like the Linux world. An exit code of 0 is usually meaning like no errors, like a program did not encounter any errors that would cause it to terminate um, during its execution, and a non-zero error, return code will usually indicate some sort of error. So we'll like return 1 or 2 or whatever, for example. And this is actually used to help us kind of run our programs as if they were little scripts, right? Where we can actually pipe output from one program to another program, but then based off of the other program, if we're returning a non-zero, we can actually like kind of take an alternate path to handle these type of errors. So uh, yeah, so that's like a basic C program, right? It just does hello world apparently. So why don't we actually run it? So in order to run our C program, first we need to change directories. Okay, we have our main C program, right? We can't just like run it as if it was like a shell script like that, right? It doesn't work that way. Even if we like kind of made it executable, right? So if I did chmod main.c, oops, chmod plus x main.c, right? We see that it becomes executable. Even if we did this, it won't work, right? It doesn't work the same way as like a bash script, but we have to compile the program. In just a moment, let me remove that executable permission so we get back to where we are. So in order to compile our program, we use something called GCC, right? So we use GCC. It's a program that you run where the input is like the C file that you have, right? And then it'll actually turn that into a binary. In Linux, that binary will usually be called a.out, right? So we have, oh, is it help? Yeah. So GCC dash dash help will actually give you all of these switches here, right? But the most common usage is just GCC and then the file you want to, give. So in this case, I'll do GCC main.c, and it compiles, right? It compiles the main.c, and if you get no output, that's usually a good thing. And we ls, we have a new executable file called a.out. And that's actually a program. That's a real binary program. When we cat a.out, we'll get uh, kind of a bunch of like garbage we're not really familiar with. It's no longer our source code, right? And so we can execute this program like we would for any script with the dot slash, right? And we get hello world. So let's make that clear, right? We'll get hello world. And notice that we have like a new line coming down here once the program exits. That's where this slash n comes from. So like if we get rid of this, right? For example, right? We get rid of that slash n, and we have to recompile our program every time we make a change. So it's not like JavaScript or Python where we kind of just like run it again or refresh the screen for our changes to take effect. We have to recompile it, right? So we have to run this through GCC again, right? And then we do a.out again. Now, notice something different here. When we execute our program that we have just compiled, notice how we don't have a new line anymore, and all this falls in the same line, right? That's what these new lines are for at the end. When you look at like C programs or C examples of people printing stuff, they'll always have a new line at the end. Um, yeah, so let's like make our change to fix it again. So we'll do a slash n for a new line, right? And again, we can't just expect our changes to just work, right? We can't just do like a.out. Oh, like I saved it, a.out, right? It doesn't work, right? We have to recompile, right? In order for us to actually get a new binary. And here we go. We have our changes again. Now, I mentioned before that this stdio, this include line here, it kind of includes all the like libraries, and one of the library functions is printf. So like, how do I know that? If I were to actually hover over or select stdio.h and actually hold on to my control key and actually click into it, Visual Studio Code is smart enough to kind of redirect you to like the definition file, like of stdio, and one of them would be printf, right? I believe. Let's see, printf right here. right? And that's like the signature, right? This is not a full implementation file. Like this file doesn't have code, but it has like definitions for like the functions that you'll run, right? So one of the things that you'll get by importing this file, this library, is the printf function, a very basic function to print out a string. Now, what happens if I get rid of this line, right? And I could get rid of this line in either two ways. I could actually delete the line, or I can just comment the line. Oops, let me try it again. I can just comment out the line. Comment out the line, right? And so single line comments in C is do the double front slash, or you want to comment multi-line. I believe it's just uh, forward slash asterisk, and then close it with the asterisk forward slash. So this will be a comment, and this is also a comment. Note that it's the double forward slash is going to only comment out the line, while this tells us to it's a comment block, right? So yeah, so we'll just comment it out rather than deleting it, okay? And then if we were to change that, save it again, one more time, right? Just by running the program, we don't see any changes. We have to compile again. So we do that. Now, before, we were actually not getting errors, right, in our compilation command, but now we are getting errors, and it's telling us, okay, well, in our function main for this main.c file, on line 4, we have a warning, implicit declaration of function printf. Okay, what does that mean? Oh, well, read further. Note, include stdio.h will provide a declaration of printf. So it's what it's saying here is that it doesn't know what printf is, but it feels like it's actually from stdio.h. So this is like VS or GCC smarts working here, right? And it actually says it right here in this note. It's like, you should probably include stdio.h, or you should provide some sort of declaration for printf, right? So we should include it. So we'll include it now. And will it work if we do this? That's our old program, right? Let me prove that out. So we've included that. Now we'll add exclamation points, right? And just starting our program again. So that doesn't work. We have to recompile. So we recompile and then we run our program again. And it works. Everything works again because we've included the stdio.h to define that printf call, or function, right? So that's like what a basic C program looks like. It's very simple, right? Small steps at a time, right? But I think the most important thing to know for anybody coming off of like interpreted languages, for example, is that you have to compile again in order to see changes, right? At least for now, right? So, yeah, so that's what the book is saying. Again, probably saying the same thing. Exercise here. Let us fill in stuff. Okay, so see, this is what the book is saying. It's like, how do you run the program, right? So basically, you have to compile it first, and then you run your program. And if you don't know what your program's called, just ls on that directory. Oh, I should probably add like a git ignore on this, right? So npx git ignore. Is it just cmake? No. C? Right? Is it? Let's see. ls la cat git ignore. Looks like it, yeah. Okay. Sure. Okay, so yeah. Okay, so this example like adds like asks for inputs and things like that, but we can do that ourselves. Yeah. So one thing to note is that there is really no real string type in C. So let's read this, okay? So um, this lady here is saying, "Wait, I don't get it. when we ask the user what the name of the card is, we're using an array of characters. An array of characters? Why? Can't we use a string or something? So, in other languages, we're used to like string types, but in C, we don't have them, right? We represent them as an array of characters. So it goes, the C language doesn't support strings out of the box. C is more low level than most other languages. So instead of strings, it normally uses something similar, an array of single characters. If you've programmed in other languages, you've probably met an array before. An array is just a list of things given a single name. So card name is just a variable name you use to refer to the list of characters entered at the command prompt. You define card name to be the two-character array. So again, they're talking about the project that they were working on in earlier pages. So I recommend just go through that. So you can refer to the first and second character as character name or char name 0 and char name at 1. To see how this works, let's take a deeper dive into the computer's memory and see how C handles text. Okay, I think I'll leave that here for today. At least we know how to, type a C program, save it as a file, and actually run this. So maybe just play around, just typing like random text on the screen. Yeah. I think tomorrow we'll continue and we'll read this. What about these strings? So before we do that, let's kind of commit our changes. Okay. So oops. Okay. I guess we'll do git commit. Let's learn C. Okay. Done. Let's go to our Git repo. I'll probably favorite this. Let's favorite. So let's do average dev, and then we'll say GitHub. Let's say done. There we go. Yeah. Till next time. Bye-bye.